Hey guys, Ms. Davis here again. You are watching Unit 2, Skill 3B, the inverse of functions, Part B. So pause the video and take a moment to write down your essential question. How do we find the inverse algebraically for more complex functions? So our steps are going to follow the same as we did in the last video. So for example, it says write the inverse equation of the following function, h of x equals this here. So we're going to start by rewriting the h of x as y. So get rid of that and call that y. And we're still going to do the switching of the x and the y. But this time, we're just dealing with equations that have things like x cubed in them, and we're going to be dealing with some other GCF fun stuff, okay? So after we switch the x and the y, so switch them, we're going to rewrite this as x equals y minus 2 to the third power minus 1. Okay, and we're still solving for y. Okay, so if I want to get y by itself, we have to start moving everything away from it to the opposite side of the equation. So I'm going to get rid of that constant term, the positive 1, and add it to both sides. So I get x plus 1 equals parentheses y minus 2 to the third power. Okay, so our next goal is to get rid of this exponent of 3. Now, if it was a 2, if it was squared, then we would just square root both sides because that's the opposite of squaring. But in this case, we're going to do something called cube root. So this new symbol you're about to learn about looks like a square root symbol, but it's got a little 3 in the little check mark there. This is called the cube root. And that is how you undo an exponent of 3. So I'm going to go ahead and make the cube root of this side and do the cube root of this side as well. Okay, so when you do that, that cancels out the cube root and the exponent of 3. So you're left with, on the left side, the cube root of x plus 1 equals, you can drop the parentheses too and just rewrite what's underneath that cube root symbol, y plus 2, or y minus 2. So now our last step to get y by itself is just add that 2 back to the other side. And when we do so, we're going to end up with, let's see, those 2's cancel out. And when we write this over here, you can't add that 2 onto the x plus 1 in whatever's underneath the cube root symbol. So you're just going to tack it on the end. So it's the cube root of x plus 1 plus 2, not underneath the cube root symbol, equals y. Okay, so I'm just going to rewrite this with y on the other side, and actually I'm going to replace it with h inverse of x just to get our formal notation. Whoops, so h inverse of x, which I'm replacing with y, is equal to the cube root of x plus 1 plus 2. Okay? So same procedure, just a little bit different steps with undoing those cube roots. So now we're going to get into some fraction equations. So write the inverse of the equation. That always means switch x and y. So I'm going to start by rewriting it as y equals 2 over n minus 2 plus 2. Okay, so the second step then is to switch. In this case, we're going to be switching not x and y, but switch n and y for this inverse function. Because there's no x, we can really call the n and x if we would like in our heads. Okay, so now I'm going to switch them. So I'm going to write n instead of y equals 2 over y minus 2 plus 2. Okay, all right, so now our goal is to get y by itself there on the denominator. So I'm going to start with the thing that's furthest away from it on that side of the equation, and it's that constant term with no variable or anything, is that positive 2. So I'm going to get rid of that guy, bring him to the other side, and get n minus 2 equals 2 over y minus 2. Okay, so now in this case, what we want to do is we want to try and think about this next step here as a cross multiplication problem. So if I put this over a 1, now I've created a fraction equals a fraction, which means that we can go ahead and do some cross multiplication there. So if I do the n minus 2, so whenever I multiply two things times anything, we always want to use parentheses. So in this case, I've got two things that have parentheses around them. So it's going to be n minus 2 times y minus 2. And then going the other way, if I go this way, I get 2 times 1 is just 2. Okay, so I'm still solving for y, so we want to think about how could we get rid of, we could actually get rid of this whole n minus 2 all at once. If it's n minus 2 times, there's a multiplication symbol between them, times y minus 2, I can just divide that whole n minus 2 term and cancel it out all at once. And I can do that over here too. So if I do that and I take the whole parenthesis and divide by it, then I just get rid of it altogether. So now that I'm left with just y minus 2 with parentheses, I can drop the parentheses since there's nothing to multiply by outside here anymore. So it's just y minus 2 equals 2 over parentheses n minus 2. Okay, and then our last step to get y by itself is to add that 2 to the other side, so plus 2. I'm going to bring it up here. So I'm left with just y equals a 2 over n minus 2 plus 2. Okay, so again, that 2 we're just going to tack on the end because you can't combine it with that fraction at all. And once we have nothing left over to multiply by over here, we can drop those parentheses and just write n minus 2 without parentheses. So again, I'm going to rewrite this as, this is f inverse of n is equal to 2 over n minus 2 plus 2. Okay, so go ahead and flip onto the next page. Okay, so for these ones we've got g of x equals, and then a binomial on the top of the fraction and one on the bottom. So our first step is always to rewrite this as y equals, and just copy down the x side. Okay, so second step in this case is still going to be switch your x and y's, so it'll be x equals y minus 4 over y plus 3. Okay, so this one's a little bit more, has more steps to it, but if we have a single term equaling a fraction, we want to put that single term over 1 and do some cross multiplication. Okay, so I'm going to cross multiply, and I'm going to have, let's take the first, this x on the top. It's going to be x times, now I've got y plus 3, we want to put that in parentheses because it's got more than one term, so y plus 3 is equal to, going the other way, 1 times y minus 4 is just y minus 4. Okay, so now at this point we're solving for y, but we have y's on both sides of the equations. So to get ourselves in a little bit better shape, we have to distribute that x and see what we can do from there. So x times y is xy, plus x times 3 gives us 3x equals y minus 4. So at this point, we want to look at where our y's are and get them all on the same side. So we have a y over here and a y over there. So what we want to do next is move all of our y's towards one side. We could go either way. We can put them both on the left, or we can put them all on the right. I'm going to start by going ahead and taking this y on the right and subtracting it to the other side here. So rewriting it over here. And then what you also want to do, so let's do that first. So we'll get xy, I'm just going to write the minus y right near it, plus 3x equals negative 4. And then you want to get your x's on the other side. So I'm going to take that 3x and move it to the other side. So you want all y's on one side and all x's on the other side. The reason why I wouldn't move this one right here is because this one has a y in it. So we want to keep that term. You can't separate them yet because they're attached through multiplication. So at this point, we're left with xy minus y is equal to, I'm going to write this as negative 3x minus 4. So at this point, we're almost there in getting y by itself. But if we look at this right here, we can factor out a y, and so you're taking out a GCF of y from x times y minus y. So I'm going to take out a y and take it out as a GCF, and then think about y times what would give me xy back? X. Y times what would give me back minus y? Negative 1. So we have undistributed a y, and we're left with that equaling the right side. So now to get, so there's a multiplication symbol there between y and the parentheses now. So if I want to get y by itself, I'm just going to divide by the parenthesis of x minus 1. X minus 1. Okay, so those cancel out, and you're left with y equals negative 3x minus 4 over x minus 1. Okay, so that's one way that you can write the inverse, and I'll just rewrite it as, again, f negative 1. Is it f prime? Hang on, let me see. No, this was g. So hang on. So it is g to the negative 1, or inverse x equals negative 3x minus 4 all over x minus 1. So there's one way to write our answer. If we pick up from where we were up here, so at this step right here, a little bit more towards the top, this one here, if I rewrite that down here, we could have went a different route. So xy plus 3x equals, so let's write that down. So xy plus 3x equals y minus 4. So we could have chosen to bring everything to the right side for our y term. So I could have moved the xy to the other side to get it near that y. Cancel those out. Write out 3x equals y minus xy minus 4. Add the 4 to the left side to get it with the x. Cancel that out, and you get 3x plus 4 equals y minus xy. And then down here you would have a GCF of y, so it would be y pulled out would be 1 minus x equals 3x plus 4. And then you could have divided both sides by 1 minus x, divide by 1 minus x, and you would be left with y equals, 3x plus 4 over 1 minus x. Okay, so we could also rewrite that as g to the negative 1 of x equals 3x plus 4 over 1 minus x. So if you look, this one here is actually the same thing as that one. It's just that this one on the top had negative 3 and negative 4, and on this one is positive 3, positive 4. So those are, they're like the same thing, because really you're just multiplying everything by a negative 1. And then on the bottom we had a positive 1 and a negative 1, and now a negative x and a positive x. So those are actually the same thing. It's just the negated version of it. Okay? All right, so let's try one more. So we're looking up here at g of x equals that. So step 1, rewrite as y equals x plus 9 over x minus 2. Switch your x and y, so we write it as x equals y plus 9 over y minus 2. Okay, let's turn that into a cross multiplication problem and cross multiply. So we get x times that whole y minus 2 binomial down there equals 1 times y plus 9 is y plus 9. Okay, so go ahead and distribute to get xy minus 2x equals y plus 9. Okay, so we want to get our y terms on one side, so we can take this 1y and bring it towards the other y, so by subtracting it to the other side. So we get xy minus 1y minus the 2x that was there before equals positive 9. Okay, so from here, this guy right here doesn't have a y at all, so I'm going to bring it to the other side and rewrite it as xy minus 1y equals 9 plus 2x. Or you could write it as 2x plus 9. Okay, at this point we've got a y here and a y there, so we can factor out a GCF of y times x minus 1 after we take it out of both, equals 9 plus 2x. Okay, last step here, divide everything by x minus 1. We're almost there, getting y by itself. Cancel those out, and we're left with y equals 9 plus 2x over x minus 1. And then rewriting that as the inverse there, we're going to have, what was it again? G inverse, so g to the negative 1 of x equals 9 plus 2x, or 2x plus 9 over x minus 1. Okay? And another way you could see it written is g to the negative 1x. If we solved it the other way, like we did over here, you just basically change all the signs. So negative 9 minus 2x over negative x plus 1. So if you switch all the signs, it's the same thing. Okay? All right. Go ahead and answer your summary reflection questions and head on over to the practice.